so you can follow me? Okay, I'm going to explain a little bit about our upstream injection system. What we do is we use a system that is electrically controlled. The advantage of this system is that it allows us to pick up soap from a container without having to use any type of restriction. It's the way we pour it into the pump what makes a difference. But anyway, the way it works is this is an on-off switch, an indicator light. We have a solenoid that switches on and off, allowing chemical to go into the system or not. What controls the solenoid is this flow switch. The reason we have to cut it off is because when you release a trigger gun, you don't want any soap to continue being injected into the pump. So this is what actually stops it from flowing into the pump. While on bypass, press the trigger gun again, then it reactivates because of the flow switch engaging, and then the solenoid opens up and allows the chemical to go through this micrometering valve. The sole purpose of the valve is not to shut off and on the chemical supply, but it's only to meter it, because if you had it fully open, there will be an enormous amount of soap. So that allows you to throttle it down to set it to, the amount that is perfect for the work you're doing. The way it works too is this switch is not active until you turn on the ignition switch on the pump, and then when you turn on the switch, the green light comes on indicating that it's on call, it's ready to go. And that's all there is to it. We have to use a bypass loop, since we're not allowed, because of the chemical, we can't dump the water back into the bypass water into the tank, because it will gradually contaminate the water, and then it will become more and more saturated with soap. So it requires to have this external bypass. We provide enough hose to slow down the process of overheating, because on a closed loop, if you leave the machine on bypass for an extended period of time, the water will get extremely hot. So basically we put this relatively long loop with a 3/4 inch hose in order to prevent that from happening. That hose is also attached directly to the bypass on the unloader to prevent excess air sometimes that will cause what they call burping, where air bubbles go in for an extended period of time before you actually have a good flow. So with this system, you don't have any of those problems.
What did this customer have this build done for? What are they doing?
I'm sorry?
What's this? So this customer is doing this for fleet washing.
For fleet washing?
Yeah, it's specifically for fleet washing.
Oh, okay. Yeah, I mean, an upstream injection is great because it allows you to apply the chemical under pressure, which kills two birds with a single shot. Downstream injection, you have to apply the chemical separately, let it dwell for a while, then you pressure wash it. With this system, it's like back in the 80s, you just did one pass and you did the whole thing except rinsing.
So our viewers are going to have this question, and this is something that people argue with me all the time, but you've been doing this for 40 years now, literally 40 years. What does upstream injection with a degreaser do any damage to the pump? And if it does, what does it do?
No, you have to be careful. You cannot run any acids on an upstream system, but a highly alkaline solution is fine. For example, we use has a high content of caustic soda.
Our soap.
It does not do any harm to the wetted parts like brass, the packing material.
Does it make anything wear down faster as far as the pump?
Not that I could observe. I mean, back in the day, you had people that use chemicals, people that don't use chemicals, and the durability of the pumps wasn't related to whether the chemicals were used or not. Okay. Except when people were running acid, and that definitely would destroy a lot of things.
Bleach will also destroy the pump.
Yeah, bleach is absolutely, that's extremely corrosive.
Do not upstream bleach through these pumps. This is for degreaser. Now, other than fleet washing, I know some people actually do this for sidewalk washing, because a lot of people don't know this, but with upstream, you can use more than half of the chemical you would use whenever you're downstreaming, so you'll blow through less chemical.
And you can apply your soap at high pressure.
You can apply your soap at high pressure, so it also helps your soap seep further into the pores of the concrete. And if you're running with hot water, whenever you're running heat with high pressure and the soap the sodium hydroxide reacts much more whenever it's heated up.
And then if you're using our soap too, which has it where it helps it penetrate into the concrete
yes,
better.
there's a leveling agent in our soap too that actually helps the soap seep further into the porosity of the concrete, so you can get those oil stains another shade lighter. That's a big advantage of it because it has a penetrant. But then whenever you're using upstream injection, you're actually help force that soap into the porosity of the surface. But yeah, Dad's been doing upstream injection forever. I run it in the field myself.
I've never seen a system like this. I love it.
Yeah, Amber showed me what she used to sell for upstream, and I go, "That's an upstream set, man. That's not how I'm used. I'm used to. This is how I'm used to seeing an upstream set."
I mean, there's a simpler way of doing it, but it relies on a conventional float tank. You can't have a large tank like this.
Let me ask you though. So we're doing this electric one. Why is it that the manual ones are no good as far? Because you explained it to me before, where the water level in the tank.
Well, no. What happens is this: back in the day, particularly electric units were very common, and the float tank was built within the heating coils.
Yes.
Most machines, good machines, were hot water
like
units.
that one we have
Yeah,
over there. That
the
used to be on
rental
Whitco.
The tank itself has a float valve, so the level was like on a carburetor, where the level was constant. And what happens is, in order to create enough vacuum to suck your chemical, from the bottom of the tank, you had the inlet hose going into the pump, but it had a small had a restrictor to create a small amount of vacuum, like 1 to 1.5 inches of vacuum. That allowed chemical from being sucked from a separate container into the pump. Since you have a pressure that is lower than atmospheric, so soap will go in. The problem with these tanks is you have a high fluctuation from top to bottom. So if a customer uses it always
At full water.
at full level of water, that wouldn't be a problem. But the reason most contractors use a large tank like this is because sometimes water supply may be an issue, so you're going to have a great fluctuation from full to empty. What happens is, if you put a restriction for when the tank is completely full to make sure that it allows enough vacuum to get enough chemical, as the water level dwindles, it goes down, the amount of vacuum will increasing the consumption of soap, because you have a fluctuation from a high level to a low level. Whereas on a regular machine where you have a float tank with a float valve and the level is maintained constant, then the amount of vacuum is also constant. We don't have the advantage of that on these mobile systems because of the tanks. Sometimes they're very large and tall tanks, so you have quite a bit of a fluctuation from full to empty. So what we do is I use a principle that where you have the inlet of the water, the main inlet where the water that supplies the pump, on the opposite end of the port on the opposite end, it always has a certain amount of vacuum due to internal restrictions. In other words, we don't have to use any type of restriction on this line because the restriction is internal into the head of the pump. The problem with that is that you have enough vacuum to suck chemical, but if you go on bypass, it'll keep sucking chemical because here will remain with a residual vacuum, where here, even though here you're on bypass.
So it'll keep sucking chemical, and then it gets more concentrated.
And if it goes long enough, it can be pumped back into the supply, which you don't want to do that. That's the reason this is a little more complicated, because electrically we use a solenoid. So when the machine goes on bypass, then the flow switch disengages, takes off the power from the solenoid, so it doesn't allow the chemical to continue going through until you press the trigger again.
And then I wanted to cover, because we talked about the importance of getting a good trailer for your build.
Oh yeah, that's another issue. Many contractors in particular think, well, maybe I can skimp on the trailer because I'm spending quite a bit of money on the equipment, but the trailer is essential, it's very important. And I give you an example. This unit is not in itself a bad trailer, but see, this trailer was designed for landscaping. Look at the tailgate and everything else. It's a carry mower. It's for a different function. What happens? We rely on these surfaces on the railing to mount components. It's very practical. But guess what happens? This type of trailer, unlike heavier duty trailers,
like the Ranch King,
instead of a 1/4 inch angle, and then on top of that they use square tubing, which is far more rigid. This is 1/8, 2x2 by 1/8 angle. And when this engine is running, being a single cylinder, it induces a lot of vibration, and the vibration is transferred to the frame. So you have vibration on the box and all this, which is less than ideal. In other words, the components will last longer if they're not subject to so much vibration, because a constant vibration can cause electrical components eventually to fail a little earlier. And that's one of the problems. That's why we always insisted that our personal preference on trailers, because of our experience going through a number of different manufacturers, King Ranch.
Ranch King.
Ranch King,
Yes.
I'm sorry. Let me reverse.
King
Sorry about
Ranch.
that. Ranch King, and those are the best built trailers, and they are marginally more expensive than others, but they're far better. They use 7,000 pound drop leg jacks, which are a lot easier. Like this jack works, but you have to unscrew the whole thing all the way, screw it back in, takes a lot of time. The other ones, you just lift it up enough. Once you hook it up, retract the drop leg, and then we're good. It's like on those trailers back there.
Yeah.
They are 7,000
Has a
pound
locking pin,
capacity.
so you can not have that
Just
problem.
to see the difference.
This is one of my older
Also, you
trailers.
can show the plumbing. You know, I have all these this clamp, which by the way, I need to get some more. See, the way we do it is we clamp everything down neatly. We leave enough
Very
space
nice.
for equipment. We had to remove this wheel because this manufacturer in particular, this setup was very flimsy and was shaking. So we're going to tell the customer he can mount it somewhere else. But also we envision that the customer may in the future want to do something else or add equipment. So we left on purpose this area because there's a possibility the customer may want hot water in the future. And instead of having to spend money on an entirely different unit, trading this one in at a loss, he can always add a vertical hot box to the existing system. We only use engines that provide 20 amp minimum on the charging system.
18.
Or 18.
Yeah, 18.
Even on cold water units, because I'm envisioning that the customer at some point, they may want to have heat. That way they don't have to say, well, that the engine is no good because it
We
has
deal with
only
that with a lot of
5
people that have pull start
Yeah.
engines. They're like, well, how can I convert it to a key start? I'm like, you can't. You have to get a new machine.
That's why when customers call and they want a power washer, what is your plan is what I always ask them,
Yeah.
so I can find out if they're going to want hot water at some point.
Yes.
We can go ahead and get the electric
Because
started.
you're not going to want a pull start if you plan on doing gas stations full time.
Yeah.
That's just, you don't want a pull start. You want it to be a key start with at least an 18 amp alternator so you can power 12 volt.
This is a really nice setup, though.
Yeah, it has two 20-gallon upright tanks. One's for R-Soap 2 and one's for R-Soap 1. They're going to be alternating. You know, R-Soap 2 is the one for property maintenance cleaning, and then R-Soap 1's our brushless truck wash. This one's going out to Los Angeles.
Nice.
So,
And batteries, we always put group 24.
Yeah.
It's an overkill, but it's a very common battery. It's a very common size. They're widely available. If the battery runs down for one reason or another, they're deep cycle batteries, so they're less likely to completely die out.
why do we use deep cycle over automotive? I've been seeing people have
Because-
debates on Facebook thinking that automotive batteries are the way to go.
No,
and
what happens is this. Back in the day, this is tradition. Back in the day, the burners weren't very reliable. The charging systems weren't capable enough. And many manufacturers started building machines with 12-volt burners because they were far less expensive. Because the only alternative you had at the time was to use an expensive generator and then use a 120 or 240-volt burner. So the 12-volt burner eliminated the generator, which even at the time was like $300 or $400. Now we're talking about 80s, 90s, so that was quite a bit of money. So everybody went with the 12-volt systems. The problem is the first systems, well, they used about 15 amps like it is today.
yeah.
But most engines had a weak charging system. You know, there were 5, 8 amps. The purpose on small gas engines
Was
of
just
the
to start.
generator was just to charge the battery for the occasional start. So whether occasional, you don't start the engine somewhere all the time. So they weren't designed to supply ample amount of current.
So why are we using the marine deep cycle batteries instead of the automotive?
Because back then what happens is customers will buy, they had initially small batteries. But then what happened is the burner will start burning dirty because the voltage kept going down. What it meant is that the charging system was putting out less power than the burner was consuming. So they said, oh, let's put a bigger battery. I said, well, all you're doing is delaying the agony of the batteries is longer. That's all.
Yeah.
Because you're still sucking more from the battery than what the battery is receiving. So eventually it's going to start causing the same problem. Black smoke because you don't have enough air.
Okay.
The speed on the blower drops. So you have a problem with combustion. So it's the
old school guys. They used to always want the 120 volt burners, and I'm like, no, you can do the 12 volt now.
No, the 120 volt
but
burner today.
what's the
I don't hear
advantage
about those anymore.
What's the advantage of a deep cycle battery over an automotive battery?
You can discharge
You
the
don't need
deep
it.
cycle further without destroying it. Because
So discharging an automotive multiple
Yeah.
times causes it to die faster.
Yeah, what happens is
Okay.
on a Group 24 deep cycle, it has fewer but thicker plates. What it means is you have less cranking amps, but as the battery is being depleted, some of the lead is dissolved into the electrolyte. In other words, on a car battery, if you drain it enough, most of the plating, which is thin lead, and they do it on purpose, that way they can have multiple plates to increase the cranking amps, then they dissolve into the electrolyte, and they cannot be recovered when you recharge because the electrodes are pretty much devoid of all lead.
Okay.
So this battery is worse, so it'll last longer. So under warranty, the manufacturers don't have to supply new batteries constantly.
Okay.
And that's one of the reasons
So automotive batteries should just never be used
That's
on
old
pressure.
school. That's for people that wanted the 120 volt burners.
No, you can use, today is not a problem because all the charging systems have plenty of power. You can use any battery
Okay.
as long as it produces enough. And in fact, you can run a battery the size of a motorcycle and should be good because the actual power is what the charging system supplies.
Okay, so it doesn't matter anymore if someone uses automotive.
The battery
or
is
deep
only
cycle.
a reserve. If
Okay.
you had a small battery like this, just to be able to fire up the engine,
Yeah.
that's all you need.
Like those U1s.
Yeah, because the alternator on the engine
did not
should
know that.
provide more current than the burner. That's a simple, the simplest way to explain that. And that's the reason why you can still find igniters with a photocell, because once you have a flame, you don't need the spark, and the igniters, they use 5 to 6 amps. Back then, it was very critical. So by cutting off the igniter, once you have the flame established, then the only thing drawing power was the blower motor around 8 or 9 amps. And there were several engines that could produce that much power at the time. But nowadays, it's not a problem. 12 volt burners are the way to go because the reliability is pretty much almost identical as compared to the AC components, like the 120 and the 240 volts. They have improved the quality of the motors, everything. So there's no reason why anybody should use a generator. Besides, some people say, well, I like a generator for a light, but no, the generator is supposed to be strictly dedicated to the burner, because if you put other accessories, you may impair the functioning of the generator. So no, it's not an advantage. If you need a generator for lights, get a separate small unit, inexpensive ones with a small gas engine, and run it completely separate. Now, that will be an acceptable option,
Okay.
But that's
When are we going to see this thing in action?
So we're going to get this thing live here. We're going to need to get some water in here, and then we'll go live and show how upstream injection works. We can probably clean some concrete.
So we're going
or
to do it
something.
here shortly.
We'll do it here shortly within
Okay.
the next 20 to 30 minutes.
Raj wanted to know and said hello.
Yep, and then we're also going to have a video. And if you missed the live and don't make it to it, we are going to make a YouTube video with it as well, and we'll have it on our YouTube channel. For those of you that don't know, it's the Washmart YouTube channel. So, all right,
We'll
Dad,
see you soon.
appreciate it,
No.
and we'll get this going.